Alright, so this could be our next note. This is on congruent triangles. This is lesson 4.2 from your book, the next lesson. And here we're talking about something that's congruent, or congruent triangles. And if you remember, and I'm sure you do, the congruent means the same as, really almost equal to. And here we have two triangles, ABC and DEF. And we might ask, are these triangles congruent, right? How could we figure that out? Okay. Now we could cut them out, right? We could cut them out and then place one on top of the other, see if they're the same distance. But there's also other ways to check, and one of them actually ties into that. So one common way is something we've been doing, and that is transformations. So if you remember, some examples of transformations are rotations about an axis or an origin. Translation is moving it from one spot to the other based on a specific x and y for each point. They move the same. And then a reflection would be about an axis, so maybe the x-axis, the y-axis, maybe y equals 3, x equals 2, whatever it is, but we rotate that about that axis, and that's called a reflection. So if you look at this one here, we could rotate it maybe a certain amount, so it's up against this, at the bottom of this triangle, and then we could reflect it over an axis, some x-axis, and we could then see if they line up. Okay, that's an example of using a transformation. But also we can use something else, and that's comparing sides and angles. And a lot of times you'll see in geometry they use notations to do that. So let me show you what we're talking about here. So you might see a single triangle. It might have some notations on it, like we might have a line here, and maybe even a line there. Okay, and that would tell us that these dash marks here are all the same. And what that means is that each one of these sides are the same, and we could call that an equilateral triangle. But also we can use these same kind of marks to help us with seeing whether two different triangles are congruent. And you might see within your textbook, you might see this triangle DEF also has a 1 mark on it. Okay, and then maybe this side over here has a 2 on it, and then this last one has a 3. That would then tell us that each one of these sides, AB and DE, are congruent. Side BC and EF are congruent, and we could say it the other way, CB or FE, it doesn't matter. And then DF and AC are congruent as well. Those notations tell us that because they're the same. We can then do the same thing for angles. So we could say A, and the angle B is 2, and angle C is 3. Then we could say angle D has 1, and angle A has 1, so they're congruent. Then we could say angle E has 2, and angle B has 2, they're congruent. And then if angle F had 3, we would then know that these angles are congruent as well. And if you remember the third angle, the thing about the third angle, that I'm not sure if we talked about that, maybe we did, maybe we didn't. But if we know a triangle has two sides that are congruent, we know that the other sides must be congruent as well. A third angle theorem. Okay, so let's look at how this might be useful as well. So if we know these things are congruent, and maybe we look at the notation, or maybe we do a transformation, we see they're congruent, we can then use it to figure something out. Okay, I'm going to kind of cover this up at first. So let's say we have these triangles here. So we can get this to focus a little bit. Okay, so say we have this one triangle. It's got all these parts labeled on it. It's got the angles, it's got the sides, and they're all in there. And then we have this other triangle. It has very little. It just has an angle, and it has 8y minus 5. Okay, and then we have over here this side is equal to 2y plus x. And we want to use algebra to solve for some unknowns and figure out what x is and figure out what y is. And this is kind of a simple example, but then we kind of take this as we're going through triangles and congruence and stuff, and we'll take it to the next level as we proceed. Okay, so the thing we have to always know is true, though, is to compare these triangles to each other, they have to be congruent. So the statement has to be the triangle ABC and triangle DEF are congruent. We might have done a translation from here to here and measured the distances, and if they're the same, we know they're congruent, right? So if you measure B to E and it's 5 inches, and then we measure C to F and it's 5 inches, and A to D and it's 5 inches, then we know that we're good, that it's congruent. So then how can we use that fact? Okay, so the first thing we would want to do is we have to solve for x and y. So we'd have to ask ourselves, which one do we want to solve first? Here we have a y and an x that's an unknown. Here we just have a y that's an unknown. It's referring to the angle. So we're going to solve for one unknown first. So then we do that by just saying the 8y minus 5, right? And we know because these triangles are congruent that this one is 99, so this must be 99 as well. Then we go down through the math. We're going to add 5 on both sides. Then we're going to divide by 8. And we end up with y equals 13. So then we know what y is. We can then plug that into this next part here. And then we could say 2y plus x equals this side. This refers to this side, so if this is congruent, that should be 38.4. We're then going to take 2 times 13, plug that in for y, because we figured that out. That's going to be 26. Let's do it. 26 plus x equals 38.4. Then we're going to minus 26 from both sides. And we're going to get x equals 12.4. And that will be our measurement. Okay? So then we could solve, this helps us solve for things that we don't know. And then we could plug that into there to see if this side is actually congruent with the other one. So then we could take our x, and we could take our y, and we take this part of it. So we say 2y plus x equals, it's going to be equal to 38.4. So we plug in 2 times 13 plus 12.4 equals 38.4. 26 plus 12.4 equals 38.4. And you'd see that they are equal to each other. 38.4 equals 38.4. So we know we're correct. Okay? So that's how we can use algebra. You know, I see here we didn't do the third angle. I was thinking of this notes. So there's another thing that goes along with these triangle angle sum theorem, and that is this third angle theorem. Okay, and I kind of mentioned it before. I thought we had it in notes, but we didn't, and that's fine. And what this one says, if two angles of one triangle are congruent to two angles of a second triangle, then the third angles are congruent as well. Because in the end, they all have to be equal to 180 degrees, right? So if we look at these triangles here, we have triangle ABC and triangle LK or LJK, or however you want to say it. And we see K is equal to C and B is equal to J. And because these two, this is congruent with this and this is congruent with that, then A and L must be congruent. Okay? So we know that just by this law. And we know because it has to be equal to 180, right? So it kind of makes sense that that's what it should be. Okay. So then how do we use this third angle theorem? Okay, and we're going to do a proof here. Don't get too upset though when you see this, but it's not that long. Okay, so let's say we got this condition where we have these two triangles, one right up against the other. And you can see we got some notation here. So really we got this triangle DEF, and we got triangle EFG. And we see that side DE is congruent with EG, it's the same. And then side DF is congruent with FG. And then we don't know about EF here. But we can see they're the same line, right? For each triangle, this part of the triangle is the same line, so they must be congruent as well. So then we can use these notations here to see that DE, just like I said, DE and GE are congruent. DF and GF are congruent. Angle D and G are congruent, right? Because we get this one here. This D here, this here are congruent. And then we have angle DFE. So DFE, there's an angle there, is congruent with GFE. So these angles are the same as well. So then we know that they're congruent as well. And it says prove triangle DEF is congruent, or the same as triangle GEF. Okay, and this one's pretty easy. Just want you to write it down, have it in your notebook. So we start off with what we know is true. And we have, first of all, we have DE line is congruent. This one is congruent with EG. So that's a given, right? And we also have DF is congruent with GF as well. That's a given, okay? And then we need this line right here, okay? And this relies on, so line EF is congruent with line EF. And that's called the reflexive property. If you remember, we haven't talked about this one for a while. But the reflexive property really just says, if we have something like triangle ABC, it's congruent with triangle ABC. It's really just saying that any value is equal to itself. Like 1 is equal to 1, 3 is equal to 3, 75 is equal to 75. Any amount is always equal to itself. That's reflexive. Because these are the same lines, right? So EF is equal to EF. It's the same. Okay, so that we use the reflexive property. And then we kind of use this angle D and angle G. So we got these. We want to restate that. We know that they're congruent. And we know this DFE and GFE are congruent. That's another given that we have. Okay, and then we can use the third angle theorem because we have this angle and we have this angle on this triangle, and we have G and we have F on this one, and we know that they're congruent. So since G is congruent with D, and F is, or this whole angle DFE is congruent with GFE, then we know that this angle we don't know, that it's also congruent. Okay? So then we can just say DEF is congruent with GEF, the third angles theorem. And then finally, we can then say, because of all that, so if this angle, and this angle are the same, because that's the only thing we don't know, if the angles are the same and the sides are the same, then we know that they're congruent, or the definition of congruent angles. Then we can say triangle DEF is congruent with triangle GEF. Okay. And just a reminder about some of these properties as well, what they mean. The reflexive property we already talked about. The symmetric property, it says that if triangle ABC is congruent with triangle EFG, then triangle EFG is congruent with ABC. So the order that we say them in, or the order that they're presented, doesn't matter. They're still the same. So wherever their symmetry is, wherever you put the line and divide them, it doesn't matter. They're the same. And then finally, the transitive property. This says, so if you have a triangle ABC and it's congruent with triangle EFG, but then we have a third triangle, and we say triangle EFG is congruent with another triangle JKL, then we conclude since ABC and EFG are congruent, and EFG and JKL are congruent, we can then say ABC is also congruent with JKL. So that's kind of your notes for this, a little bit shorter. I hope they make sense. And I'll put them in your notebook, and you'll be ready to go in class tomorrow.